In this section, we'll see some practical applications of integration. The agenda is that firstly, we will prove that an accumulator acts as an integrator. And later on, we'll use this integrator to integrate equation of a line and also a cosine signal. So let me just explain what I mean by accumulator. Accumulator is nothing but it's a adding device. As in when a new input becomes available at T1, it gets added to the previous input and the result gets stored. And this added sum, aggregated sum, is multiplied by the time step and the result is stored again. And in the next step, when input becomes available at time T2, that is x2, it gets added to the previously stored aggregated sum, and again it gets saved, and the whole process repeats itself. So for illustration purposes, I've shown two arrays here. One is the input array x and the output array y. The output array y is the aggregated cumulative sum of the array x. So how it works is that when number 1 appears, it gets added to its previous number. Since there's no previous number, we assume it to be 0. So 1 added by 0 becomes 1. So that's the output. Then number 2 appears, 2 gets added to 1, and the added sum is 3. Not to forget that the difference between these two is just 1. In fact, all these numbers is just 1. So this delta t here becomes 1, and so all the numbers are getting multiplied by 1. So if you see this array, when number 3 appears, it gets added to 3, and the accumulated sum becomes 6. When number 4 appears, it gets added to 6, and the accumulated sum becomes 10. When number 5 appears, it gets added to 10, and accumulated sum becomes 15. So on and so forth, this entire array gets generated. And the objective here is to show that integrator works as an accumulator, and we will implement this algorithm in Python. Then once we have implemented this algorithm in Python, we'll use this accumulator working as an integrator to integrate the equation of a line. And we all know that equation of line is mx plus c. So when we integrate it, it becomes cx plus mx squared by 2. To keep things simple, we will assume m to be 1, the slope to be 1, and intercept to be 0. So when we plug these numbers here, what we get is x squared by 2. This is what is the theoretical result. And we will prove it to you that this matches with the accumulator output that we are going to build in Python. Then we'll extend this concept, and instead of line, now this time we'll take a cosine function, and integral of cosine is sine, as we all know, plus a DC term, a constant term. So we'll use this accumulator once again and integrate cos function and prove it to you that the theoretical results and the output of accumulator matches. So over to Python, where we'll implement all these algorithms and demonstrate to you in real time. So we are in Python environment now, and the first thing that we are going to do is to implement an accumulator in Python. Essentially, we are going to create an array which looks like this, and then do a cumulative sum on top of this array. So first we decide the time step. Let's say the time step is 1. That means difference between these numbers. And in Python, there's a function called a range. Here I have to specify from which number I have to start and where do I need to end. So I want to generate numbers between 1 to 10. So I'm going to use this argument. And the distance between these numbers is dx, that is 1. So that's what is my input array. I'll call it x in. And let me just print this array so that you can have a look. So here we are, we have input x, 1, 2, 3, 4, 5, 6, going up to 10 with an increment of 1 each time. So we now have our input array, and we need to perform a cumulative sum, or we have to convert it into an accumulator. So let me have an output array called yout, and how it's done in Python is by using a function called cumsum, which stands for cumulative sum. And here I will pass on this array, input array, and then I'm going to take a print out of the output. So as you can see, this was our input, and our output is the aggregated sum as shown in the PowerPoint also. So 2 gets added to 1 and becomes 3, 3 gets added to 3 gets 6. When we add 4 to 6, it becomes 10. When we add 5 to 10, it becomes 15. So this is how accumulator is implemented in Python. Now this building block is in place. So let's use this accumulator to integrate the equation of a line. Essentially, this one, x squared divided by 2 should be the output. So here once again, we define the step size. Here we keep it at 0.01, and we generate an x array which is going from 0 to 10, and we are going to print this array. So as you can see, it's a very big array, 1000 numbers. It starts from 0 and it goes up to almost 10 with an increment between each number, that is dx, and dx here was 0.01. So this is what this array looks like. So once we have done this, then we have to implement the equation of the line, which is nothing but y is equal to mx plus c. Here our m is 1 and c is 0. So we are going to generate this line and then take a printout of this line, which will again be a array as shown here. So since the equation of line is nothing, y is equal to x, because m is 1 and c is 0. So x and y are just the same. And I'm going to look at it in a better way. Instead of printing it out, let me just plot this array. So when I do that, I get, so x-axis is the horizontal line, y-axis is the vertical line, and we see that we are able to generate a line. Now idea here is to integrate this line using the accumulator that we had built earlier. So how we're going to do it is that, so firstly let me just disable this command, and what I'm going to do is that I am going to make an array which is the aggregated array, and how it's done is the way we had implemented the cumulative summer earlier using a command called cumsum, and I'm going to pass on this y value, the line, to this function. So let me just now plot both of them, and as you can see, this is the equation of line, and this is what is happening post integration. Now we need to scale this with dx step size. So and also I'll activate my general plot settings here so that we can see the plot clearly. So here you can see that this is the x-axis, this is the y-axis, this is the original line, which is x, and then which is y, and then we integrated this y and we got this curve, which is the output of the accumulator. So let's see if it matches with the theoretical results. So theory says that the integral is going to be x squared divided by 2. So let me just create a theoretical output. I will call it integral theoretical, and what essentially we're doing is mx square divided by 2, where m is 1, and multiply by cx. If you remember, this is what I'm talking about, mx square divided by 2 plus cx. This is what is the theoretical result of the integration of a line, and let's see how this whether this matches with what we have received from the accumulator. So the green line is that of the line, the blue one is the output of the accumulator, and the red dots are the theoretical results when we implement the integration in the analytical form. You can clearly see that the red dashed line is overlapping with the accumulator output, which means accumulator is working like an integrator.